Welcome. This is the second video regarding our introduction to statistics. And in this video, we're just going to discuss the research process as a whole, and then do a couple examples on enumeration. So in the previous video, we talked about the smallpox outbreak in Boston in 1721. And there was a whole research project, and we started with the question, which was, does inoculation reduce the risk of death? Due to smallpox. And then we collected some data, or we looked at the data, then we sorted the data, and then we drew conclusions from it. And it's these three steps that are a major goal of statistics. And statistics, in part, goal is to make it objective steps 2 through 4. So to streamline them, so there doesn't have to be as much thought. After the data is collected, you just run the numbers, and there's kind of a systematic approach. Now, creating that systematic approach is a very creative and difficult endeavor, but after you learn the techniques, there is a bit of stepping back and letting the numbers speak for themselves after you've invented the way to analyze them. And that's a good thing because it can reduce bias. But I want to go back to the development of the question, because I think that's maybe the hardest part, and there still is work to be done about refining that. There are ways to measure the quality of a question. And our question, which was, does inoculation reduce the risk of death, is a little vague and can be made better. So compare that question to, is the proportion of people who lived after inoculation different from the proportion of people who were not inoculated. Still a question, but it tells you directly what we're going to compare. And it doesn't presuppose any answer either. It says, here are the two statistics that we're interested in, these proportions, and we just want to know if they're different or not. So when you're forming a research question, it's important to be very specific, and the question can reveal what type of information you want. That's a good thing, because it will guide the next steps in the research process. Asking, does inoculation reduce the risk of death, really only offers one more question, which is, how are you measuring the risk of death? So with that in mind, let's move on to another question. So enumeration means counting and assigning numbers to all members of a group. When you enumerate a list, you number them. You number the items in the list. And enumeration questions are going to, like the answer to them, or like the questions will start with kind of like how many. And so we're seeking to answer how many. It's a common thing. How many people are unemployed in the United States right now? How many tigers are there in the wild? It's the most basic piece of information, but it still has to be asked. It still has to be estimated at some point. So here's our example. We're a quality control manager at a light bulb company, and we are going to ship 100,000 light bulbs. And we know that some of those light bulbs are going to be defective, but we're going to set a limit. And if we think there's more than 2,500 light bulbs that are defective, then we won't send it. Rather than testing every single light bulb, we instead just check out 800 of them and find that 17 don't work. So with that information, we're supposed to decide if we should ship the light bulbs or not. And the assumption that we'll make, we'll assume that the proportion of light bulbs that are defective in our 800 will be the same as in the 100,000. So we're saying that the proportion is what's going to be the same. So our 17 out of 800 is the proportion. And we're supposing that's going to be equal to the number of defective light bulbs that are in the whole group out of the 100,000. The proportions are what's going to be the same. Where n, the little n, is the number of defective bulbs in the whole lot. If you multiply both of these equations by 100,000, both of the sides of these equation by 100,000, those turn themselves into 1, and we're left with 100,000 times 17 over 800. N equals. And let's just go ahead and do that. Let's show that the 17 divided by 800 is 0.02125, and then we can multiply that by 100,000. You can multiply by powers of 10, just moves the decimal place over, but we can type it into the calculator for certainty. So we estimate under 2,500 defective bulbs and shipped a lot. Notice all that we ended up doing was multiplying the proportion by the total number. But it's nice to see it in this equation format right here. It'll be helpful for the next problem. So let's look at that. And now we're a wildlife biologist, and we want to know the population of a type of fishy and a small lake. So the first thing we do is capture 200 of them and tag them in some way. This could mean clipping something to them, or putting a visible mark on them in some fashion, or some way to identify them later. So after we put them, and after we tag them, we put them back in the lake. And then a week passes, and the assumption here is during that week they've all mixed themselves back up into the population and are not rejected because of their tag in their society. And then we capture 150 more and find that 21 of them are tagged. And our task is to estimate, well, how many fish are in this whole lake. So we will make this same assumption, still assume the same assumption that we did in the light bulb example, that the proportion tagged in our 150 matches the proportion tagged in the population, tagged in the whole lake. So again, we're assuming an equality of proportions. And so that's going to let us write an equation. We're going to write 21 out of 150 equals, and in this case, unlike in the light bulb example where we didn't know how many were defective, we do know how many are tagged. There's 200 tagged. And the unknown is the total number of fish, whereas in the light bulb example, we did know the total number of light bulbs. And in this case, solving for n, we should write where n is the total number of fishies. And in this case, we need to solve for n. And it's a little bit more involved of an algebraic process than the previous example. So we can multiply both sides by n and get n times 21 over 150 equals 200. And then we can multiply both sides by 150 over 21. And that will say that n equals 200 times 150 over 21. Oh, I guess I should say, these two numbers in yellow over here, they multiply together to be 1. And because you can multiply in any order, they will cancel each other out and just leave an n on the left side. Let's finish that multiplication. 200 times 150 divided by 21. So we estimate 1,429 fishies. And we round up to a whole number of fishies, just where it's not a fraction of fishies. And so that's it. Both of these questions were of enumeration. You were wondering how many defective light bulbs are in the lot, how many fishies are in the lake. And they employed a similar strategy where you collected a smaller bunch and you assumed proportions in your smaller bunch was equivalent to the proportion in the overall group. So that's it for this video. See you in the next one.